This is going on page 100 when we're done, breaking the triple digits here. And we're going to look at composition of trig functions. So this is kind of extending what we did yesterday. So we're going to start with this warm-up over here on the left side. This is what we did yesterday. So I'm going to give you a minute or so, and I want you to work through those. Yeah, the ones that say warm up in the left-hand column there. Just what we did yesterday. So remember, you're asking yourself, like on A, what angle gives me a sine value of 1/2? Okay. You can talk about it amongst yourselves. That's fine. Okay, I may not give you enough time to finish, but hopefully you're able to think through a few on your own. Now let's talk about them. So if I have positive values that I am taking the sine, cosine, or tangent inverse of, then all those come from the first quadrant. But then if they're negative, I have to decide which other quadrant I get to use depending on which one it is. So when I want an angle that gives me a sine value of 1/2, I'm really looking for the reference angle. I can still use my hand trick for that, right? This is sine, that's how I make it 1/2, so my answer is what? Pi/6. Arctangent of square root of 3/3. What reference angle gives me a tangent value of the square root of 3/3? Pi/6. Okay. Now, this one's negative. My cosine angles get to come from which quadrants? First and second. And since it's negative, it's coming from the second quadrant. So then I ask myself, what is the reference angle that gives me a cosine value of 1/2? Pi/3, right? But what I need is my second quadrant pi/3 angle, which is what? 2 pi/3. Arcsine of negative square root of 3/2, okay, my sine angles get to come from which quadrants? First and fourth. This is negative, so it's coming from the fourth. What is the reference angle that gives me a sine value of the square root of 3/2? Pi/3. So then my answer is what? Negative pi/3. Yes, it's in the fourth quadrant, but it has to be between negative pi/2 and pi/2. So I don't talk about it as 5 pi/3. Okay? Tangent, this is negative. My tangent angles come from which quadrants? First and fourth. So this one's coming from the fourth. And so what's the reference angle that gives me a tangent value of the square root of 3? The reference angle is pi/3, so my answer is negative pi/3. I know. I'm asking you step by step where some of you don't necessarily need that. I'm going to make sure I walk it through for everybody. This one's negative. Cosine comes from first and second. This is negative, so I know it's coming from the second quadrant. So then I ask myself, the reference angle that gives me a cosine value of square root of 3/2 is pi/6, but then I need my second quadrant pi/6 angle, which is 5 pi/6. Okay, we good on that? So you take the inverse of one of the ratios, it gives you the angle. When you take the sine, cosine, or tangent of an angle, it gives you a ratio. You take the inverse of the ratio, it gives you an angle. Okay, that's the way that works. We good with that? All right, so let's take this a little farther then. So it says recall, meaning we've already learned this. You actually learned it in Algebra 2, and then we talk about it again. But just for inverses in general, that if I have f inverse of x, that equals x. And f inverse of f of x equals x. That's how you verify that you actually have an inverse, right? So that's kind of what we're doing here. We are taking the inverse, or we're like taking the sine and then taking the sine inverse or something like that. And we should get the same value back, okay? But recall also from yesterday that we wrote down that the sine inverse of the sine of 7 pi 6 does not equal 7 pi 6. Right? Because the sine of 7 pi 6 is negative 1/2. The sine inverse of negative 1/2 is negative pi 6. So this doesn't work exclusively for, or just perfectly for the trig values. That's why we had to have the restricted domain and range. So basically we have a little caveat here that says this works if these things are true, okay? So here's what this looks like. Now, these are rules that you can use on some, but you don't need to because you can think through it a certain way, but then you kind of have to use on others, and I'll talk you through that as we get there. But it's not, if you understand how the domain and range restrictions work, it's not really like you have to memorize 6 new rules or anything. Okay, so it's going to look worse than it is, basically is what I'm telling you. But so let's talk about it this way first. So the arc cosine of the cosine of pi fourths. It would be nice if it was just pi fourths. It's like squaring the square root of 2. You should just get 2 back, right? This is only going to work if this angle measure is within the domain that I can actually use that for. And that is, or the output of the arc cosine, and that is the cosine goes from 0 to pi. Sorry, my brain was somewhere else. So this means that only if x is between 0 and pi, right? And it is. The arc cosine of the cosine of pi fourths is just going to be pi fourths because it fits within 0 to pi, okay? So when you do, reminder again, when you take the inverse of a ratio, you get an angle. You take the sine, cosine, or tangent of an angle, you get a ratio. When you're, sine of sine inverse or sine inverse of sine, if there's an angle in here, you end with an angle. If there's a ratio in there, you end with a ratio, okay? Because you're like undoing it and then doing it back. So that means for this to work for sine and tangent, that x would have to be within their specific intervals, which sine goes from negative pi halves to pi halves. Tangent does too, but the difference is we don't include them because there's asymptotes there. Okay. Here, if I didn't know the rules, or if I wasn't really thinking about it having to be between 0 and pi, I could still reason my way through it, because the cosine of pi fourths is the square root of 2 over 2, and the cosine inverse of the square root of 2 over 2 is pi fourths. Like, I could still get there. The problem with number 1 is you have a sine inverse of negative 1/3. That's not a value that we know, okay? I mean, it's a value that exists, but it's not one of our special values, so we don't know that. So either we don't have enough information to figure it out, or the answer is negative 1/3. Well, if I'm taking the sine inverse, that is of a sine value. Your sine values can only have a value from negative 1 to 1, right? So the sine of the sine inverse of x equals x if x is between negative 1 and 1. Like if it actually lives within the acceptable values for sine, which that does, right? Negative 1/3 is between negative 1 and 1. So that makes my answer negative 1/3. Okay. So I have this same range of values for cosine. But for tangent, it's all real numbers. So x is between negative infinity and infinity, which is not really a proper way to write an inequality, but it makes sense here, so I'm just going to leave it. Okay, we good with that? Everything we're doing on the front, these two words match. This is sine and sine inverse. This is tangent and tangent inverse. We'll get to sine and cosine inverse on the back, but here they all match, okay? And so then we can either decide, hey, maybe I have to use this rule and I can use this rule, or maybe I can just reason through what it is. So the arctangent of the tangent of negative pi halves. All right, so does the negative pi halves fit within this interval? No, it doesn't. Is negative pi halves included here? No, it's not. So what I can tell you from this is the arctangent of the tangent of negative pi halves does not equal negative pi halves. Okay? So let's see why. Let's work from the inside out. So I'm going to take the arctangent of, so what is the tangent of negative pi halves? Undefined, good. And then the arctangent of undefined, well, if it's undefined, I can't do anything with it. I can't perform any operation on it. So this one just does not exist. Now, just because it doesn't equal like this doesn't mean that your answer is does not exist, okay? It just means I can't do it that way. I got to go figure out what my answer actually is, all right? Now, for a tangent of the tangent inverse of negative 9/2. So once again, that's a value that we don't just know. That's okay. Your sine and cosine values have to be between negative 1 and 1, right? And that's because sine and cosine look like that, right? A little bit better. But tangent looks like this. So my tangent values actually go from negative infinity to infinity. So as long as this value fits within there, I'm good. Does that fit within negative infinity to infinity? Sure does. So my answer is negative 9/2. All right. Does 3 pi fourths fit within the negative pi halves to pi halves? No, it does not. So that tells me this does not equal 3 pi fourths. So we have to figure out what it does equal. We're going to take the arc sine of, so what is the sine of 3 pi fourths? Square root of 2 over 2. And then what angle gives me a sine value of the square root of 2 over 2? Pi fourths. Okay. We good? What questions you got? All right. Cosine of the cosine inverse of 2/5. Do you know what the cosine inverse of 2/5 is? Nope, me either. Don't really care. Okay. But if I can, my answer will be 2/5 if 2/5 fits in the interval that I need. Does it fit there? Is that between negative 1 and 1? Yep. So then my answer is 2/5. All right. Arc sine of the sine of 5 pi thirds. Does 5 pi thirds fit within that ratio? I mean, within the interval. It does not. So I know that the answer is not 5 pi thirds. Now, when you're actually answering these for me on your assignments and stuff, you don't have to put what it doesn't equal. I think on your notes is good, but it's okay. I mean, you can, but you don't have to do that. We just have to have what the answer actually is. So then I'm going to take the arc sine of, what is the sine of 5 pi thirds? Close. Negative square root of 3 over 2. Okay. All right. So then what is the arc sine of negative square root of 3 over 2? Negative what? Okay. Sine square root of 3 over 2, right? So the reference angle is pi thirds. This is negative, so which quadrant does it come from? Fourth. So my answer has to be negative pi thirds, which is in the same position as 5 pi thirds, but it goes by a different name, right? And that's important because it has to fit within there. All right. Cosine of the cosine inverse of negative 4 pi thirds. Well, negative 4 pi thirds definitely does not fit within that. So I need the cosine inverse of, all right, negative 4 pi thirds. What quadrant does that go in? Negative 4 pi thirds would put me in the second quadrant, right? Okay, and in the second quadrant, cosine is negative. So what is the cosine of 4 pi thirds? I'm sorry, or negative 4 pi thirds, I'm sorry. Negative 1/2. Okay. Cosine angles can come from which quadrants? First or second? And you know what? I was in the second quadrant. The problem is that this isn't between 0 and pi. So my reference angle that gives me a cosine value of 1/2 is pi thirds, right? I need my second quadrant pi thirds angle. This is a second quadrant pi thirds angle, but that's between 0 and pi. What would that be? 2 pi thirds. Okay, we good? All right, the tangent of the tangent inverse of pi thirds. Does pi thirds fit within that range that we need? It does. And if you're not sure, this is a value we know, we can do this, right? So we can say the tangent of, well, what's the tangent inverse of pi thirds? Square root of 3. And then what's the tangent of the square root of 3? Pi thirds, right? So it's okay if you know the values, you can just go through the process and not have to think through the rules. It's totally fine. It comes into play more when you don't know the values. So cosine, arc cosine of the cosine of 3/2. Does 3/2 fit within the range that we want it to? The answer is yes. What do we take the sine, cosine, and tangent of? What kind of things are they? Are they angles or ratios? Sine, cosine, and tangent. If I say I'm going to take the sine of blank, is that blank going to be an angle or a ratio? It's always an angle, right? So that 3/2 is an angle. I know it doesn't have a pi on it. It's not a typo. Okay, the angle is 3/2. I mean, sometimes they don't have pi's in them. So for this to work, the angle has to be between what and what? For cosine. What do we write up there? 0 and pi. Is 3/2 between 0 and pi? Yeah, because 3/2 is 1.5, so my answer is 3/2. So don't just assume because you don't see a pi that it's a ratio and you treat it like that, and vice versa. Okay? So here I have the tangent, arc tangent of the tangent of pi. So does pi fit within that little range that we need? It doesn't, so my answer is not pi. So I need the arc tangent of, what is the tangent of pi? 0. Okay, and then you got to be careful with the zeros, because the 0 could represent an angle or a ratio. Yes, ma'am, did I mess up? Okay, because you're always going to take the cosine of an angle, and you always take like the cosine inverse of a ratio. So I know since I'm taking the cosine of something, that something has to represent an angle. Okay, that's a good question. Does that make sense? Are we all good on that? And this obviously applies to sine and tangent, all the rest of them too. But you always take, so think about how we started. Like when you very first started trig, you were doing right triangle trig, you were finding the cosine of the angles to get the ratios and things like that. So and when the inverse gives you the angle. So this gives me a ratio, this gives me an angle. So that's how you know. Okay, so that's how we know here, tangent of pi, that pi actually represents an angle and not a ratio, because it's possible to have a pi in there and it actually be a ratio. Okay, but then when we have zeros, we got to be careful because it could be a ratio or an angle, and you can get yourself confused. So this is a ratio because we took, well, first of all, we're taking the inverse, so we know it's a ratio, right? So I have to ask myself, what angle gives me a tangent value of 0? And the answer to that is 0. In that case, whether you got it mixed up or not, we've gotten the same answer, but the zeros can throw you off a little bit. Okay. All right, so clearly 11 pi 6 does not fit, negative 11 pi 6 rather, does not fit within that range that I need. What quadrant does negative 11 pi 6 put me in? First quadrant. Okay, so I need the sine inverse of, what's the sine of negative 11 pi 6 then? 1/2. So then the sine inverse of 1/2 is pi 6. What questions do you have? Anything? So again, what we just did and what those rules apply to is if these match, tangent and tangent, sine and sine, cosine and cosine. If they don't match, those rules don't mean anything, okay? And we don't have to use the rules for all of them, but you need it on some of them. All right, so let's look at this next part here. Bless you, bless you. Okay, so now we're mixing them, which means you have to think through it and you have to work from the inside out. So to find the cosine inverse of the sine of pi 6, I'm going to have the cosine inverse of, what is the sine of pi 6? 1/2, right? And then what angle gives me a cosine value of 1/2? Pi 3rds. Okay, make sense? So here we're doing it, and then we're undoing it, but we're undoing it in a different way. So I wouldn't expect to get pi 6 out of that. All right, so then the arc tangent of, what is the cosine of 0? Okay, be careful. If I'm taking the cosine, this has to be an angle, right? The cosine inverse of 0 is pi halves, but this is the cosine of 0, which is 1. Do you see the difference there? Because I'm not asking what angle gives me a cosine value of 0. It's what is the cosine of 0. And then here, what angle gives me a tangent value of 1? Pi fourths. Very good. Any questions on those? All right. So now, sine inverse of, all right, so tangent of negative pi fourths is going to be what? Negative 1. Good. And then the sine inverse of negative 1. Okay. Heard a lot of things, heard a couple correct things, couple almost correct things. Now, when I think about my values, I think about them as positive values. So the first thing that would come to mind for me would be 3 pi halves. But can my answer be 3 pi halves? No, because it has to come from the first or the fourth, which I know that's not even in a quadrant, but we're going from negative pi halves to pi halves like this. So my answer has to actually be negative pi halves. So it's totally fine that we're thinking 3 pi halves and then think that and then, adjust it as needed. Okay, we good on that? What questions you got? All right. So then we have the arc sine of the cosine of 5 pi 6. What's the cosine of 5 pi 6? Negative square root of 3 over 2. All right, so arc sine, this is negative. So what quadrant does it have to come from? 4, first and fourth. So this one will be fourth. And then the reference angle that gives me a sine value of the square root of 3 over 2 is pi thirds, right? So then what's my actual answer? Negative pi thirds. We good with all that? Questions? All right, so now I'm going to have y'all help me with some. All right, Edward, you're going to help me walk through this, okay? All right, so I have I'm going to need the cosine inverse of, what is the tangent of pi fourths? 1. And then what is the cosine inverse of 1? Is it? What angle gives me a cosine value of 1? You were right, it's 0. I just let you stew for a second because you second guessed yourself. We good? Questions? All right, good job, thank you. Frida. All right, so here I have the arctangent of, so what is the sine of negative pi halves? Good, negative 1. All right, and then my tangent angles can come from quadrants 1 and what? 4. So this is going to have to come from the fourth quadrant. So what is the arctangent of negative 1? Negative pi fourths. Very good. All right, any questions on that? All right. Deal, thank you. Max. All right, so we have the cosine of, all right, so what is the sine inverse of 1/2? What angle gives me a sine value of 1/2? Pi 6, okay? Then I need the cosine of pi 6, which is square root of 3 over 2. Very good. Okay, we good? So we switched gears here. These first few, we took the sine and then took a operation and then did the inverse. Here it's the inverse and then we take the cosine. Okay, so it works both ways, but either way, if you have an angle that's in here, your final answer should be an angle, and most likely they won't match. If this is a ratio, your final answer should be a ratio. That can kind of help you make sure you get that right. All right, thank you. Holly. Now I realize you weren't here, but I'm gonna have to walk through it. Okay, you got this. All right, so it's the sine of.
Just time for ADA. Also, this is a reminder to be checking your crosswords when you're listening. For so fast students, we sit down during or at the end of third period to report to the dining hall for so fast testing this afternoon. Thank you.
Okay. So one thing you missed yesterday, Holly, was if I take the tangent inverse of an angle, my angles have to come from first and fourth. This is positive, so I know it's going to come from the first quadrant. So all I'm asking here for this part is, what angle gives me a tangent value of 1? Pi fourths. Good. And then what is the sine of pi fourths? Square root of 2 over 2. See, that was painless. All right, Jose. I need the sine of, okay, the arc cosine of 0. So what angle gives me a cosine value of 0? Pi halves, very good. And then the sine of pi halves is 1. You okay with that? With the zeros, make sure you say to yourself out loud or in your head, what angle gives me that value so you don't get the two things mixed up. Okay, very good. All right, Ruby. So I have the cosine of, all right, the tangent inverse of the square root of 3. What angle gives me a tangent value of the square root of 3? Remember, it's pi thirds or pi sixths. So how did I tell you how to remember which is which? Square root of 3 over 3 has 2 3s. It takes 2 3s to be a 6, so that goes with pi 6. So the square root of 3 would have to give me what? What's the only other one I just said? Pi thirds. And then what is the cosine of pi thirds? Hold up your hand. Pi thirds. This is cosine. What does that represent? If you don't speak, I can't help you. Say something, anything. Huh? 1, okay. So the cosine of pi thirds, well, this says this is a 1, but these here, this is square root of the number of fingers over 2. What's the square root of 1? 1. 1 over 2 is 1/2. Okay. All right, any questions on those? All right, so now on the front, if we had like the sine of the sine inverse of a monkey or whatever it was, if we didn't know what the value was, then we had those rules to follow. We don't have that here. Everything we just went through, we could find the cosine inverse or the sine of it or whatever. Here, when you look at this, I have the tangent of the cosine inverse of 8 over 17. You don't know what that is. I don't either. Nobody expects you to. Okay? So instead, we're going to let the, so this inside here, this is going to equal theta. And we're going to figure out, now, I'm not going to actually figure out what theta is, but that's okay. I am, though, going to draw my little triangle here. So 8 over 17, that's positive. And cosine, we're only using quadrants 1 and 2 anyway. So I know that this is a first quadrant triangle. This is my theta, right? And so cosine is x over r. So this is 8 and this is 17. And then I need to find y, right? So I'm going to find y. I'm going to say 8 squared plus y squared equals 17 squared. And then it's a Pythagorean triple. So I'm just going to tell you that that is equal to 15. Okay? So then, now that I have that, this is where my theta is coming from, right? So theta, this is this angle right here. So that means in the end, when I want tangent of theta, I go to my picture. Tangent is y over x, so that is just 15 over 8. Okay? You don't want to do that on ones you don't have to do it on. You could, but it just would not be worth your time. Okay? All right, so then when we look at number 24, tangent, my angles come from the first and fourth quadrant. This is negative, so I know that my triangle is in the fourth quadrant. This is theta. Tangent is y over x, so this is 12 and this is 5. Where does the negative sign go? On the 12, good, because that's why the quadrant matters. You get it in the right spot. Okay, So then I need to find r. So I will do 5 squared plus negative 12 squared equals r squared. That's also a Pythagorean triple. R is 13. If you don't know your Pythagorean triples, that's fine. You just have to do Pythagorean theorem, and it should be quick and easy, but I'm not going to take the time to do that. So this is 13. Remember that this is your theta that's down here in the picture. So then the sine of theta is going to be y over r, so that's negative 12 over 13. Okay. What questions do you have? Anything? All righty.